Okay, we're live. So welcome to another LSST Tech Talk. We have Severin Gaudet from the Canadian Astronomical Data Center. Astronomy, sorry. I should know this by now. You showing your screen?
I have to join first. Okay.
And you're not joined.
We were looking at video conferencing systems earlier. This is typical.
Yeah, we always have some variation in that. Okay, so it's not doing it.
Are you on EDU room or the?
I am, and I am live. So let's see. Oh, just kicked in when he hit reload. Okay, so people are slowly getting there. Try reloading your page.
Okay.
On the link. Allez-vous regarder ce hangout? Do you have to say oui?
I already said so.
All right. Right.
So, I guess I start it. And,
I must make sure that all the cast of thousands is on.
okay.
Ah, here we go. Try reloading your page. It's a terrible delay. Allez-vous regarder ce hangout?
It's delayed broadcasting.
Well, I can't mute because I'm the microphone. Oh, Severin, yeah, you mute. That's right.
There it is.
All right.
Here we go.
Okay, we're good. All right, here we go.
And share screen. Where is that now?
It's the green button on the left.
Green button.
We are dreaming of push button technology one of these days. Oh, you don't have the this toolbar here.
Nope.
Or reading the news.
I was trying to.
Okay, you start. I will do your screen. All right.
Okay. Well.
Why is it in French?
I wonder why.
I'm going to invite you. All right, start talking. Seriously, just start.
Seriously, start?
Yeah, seriously, start.
Okay. Okay. Well, welcome everyone. Familiar faces around the table. I think there's only one person I haven't met yet.
I'm Chuck Gessner, the head of safety for LSST.
Okay, this isn't going to be a dangerous talk.
Taking a break from policy.
So, in the last few years, at the Canadian Astronomy Data Center, we've undertaken a fairly major project called CANFAR, Canadian Astronomy Canadian Advanced Network for Astronomical Research. And it's basically changed the way we do business from a traditional astronomy data center into much more of a community support role. So the talk today is going to, I know some of you are familiar with CDC, and I'll take you through what we used to do and where we are today with CANFOR. So please feel free to interrupt me at any time. CDC we operate telescope collections, so 12 different facilities. We also host advanced data collections, as is in community processed data from these telescopes. We operate services for community projects plus the CANFOR system that we'll talk about. We're +2 staff, and this +2 years. These are contributions from universities who sit in our area, and we have many international collaborations. Just to give you an idea of the group and how we're structured, the development group in the center here is the group I'm responsible for. We also have an integrated operations group, which manages the systems, not sysadmins. These are data DBAs, operators, operating at a higher level. We do have some support for the low-level system administration tasks from another part of the organization. But the most important part is this part, is the science team that's integrated within the CDC. And this has been one of our strengths. In the past years, there's been attempts to remove this group from us and put them in the science group within the Institute, but this has actually been our strength. And these people have both, they have science time, but they have duty time. And this duty time is integrated with all the activities. So all the activities we undertake cut across into small teams working in different areas of our software.
Is everyone not in the science boxes full FTE for CADC service?
They're full FTE. I mean, they do have a science percentage ranging from 25 to 40%, but they all, how shall I say, really involved. So the hiring profile for these people have strong technical background, so they can actually get their PhD. And these people are actually responsible for not only user support, but also for data engineering of what goes into the collections. So, to give you a high-level view of what we do, and I'll talk more about this in detail. So we have the telescopes on one end here. We have university researchers on the other side here. So CANFOR and CDC is this enclosed area here, where services on both sides servicing these two clients. In the middle, we have all our resources, which basically storage, processing, and metadata. And as you'll see, these resources are distributed around the country. So we don't actually host most of our resources anymore. And this is a big change in the last few years. And as you can see, the types of services being used by the telescopes are very similar to the types of services by users. So you see telescope data in, but telescopes also retrieve from the archive as well. Users will retrieve archival data, but will also persist user data. So similar functions, algorithms and software come this way, processing comes, processing control, but users are also doing this on the CANFOR side. So very similar activity. So the services actually serve both client communities. I'll come back to this diagram as in sort of explain more of the architecture. From a size of operation, we actually manage a fair size collection. But if you look at these two numbers, it's because we mirror our collection offsite. So we actually have 4 copies of everything. And this is for availability and performance. So we're actually managing in the collection right now 2.3 petabytes. And even though there's only really distinct, about 600 TB of distinct data in there. From users' point of view, authenticated access, this is for both archival and user data, anonymous accesses. We do this per anonymous access. We apply a factor of about 2.2, I think, to convert anonymous IP addresses to users, because from authenticated users, we know about roughly how many IP addresses the user services from. So we apply that factor to access registered users. And more interestingly is the data that was moved from our resources to users in the last year. I mean, we actually moved a petabyte of data over the wire. So that's, the scale of our operation has increased tremendously, primarily because of the community services that we provide. So a bit of history. Also, in line with this is our own evolution from a bunch of collections which were siloed into basically realization that as we got involved in the IVOA, for example, working in VO, where the goal is interoperability, we didn't even have interoperability with our own center. And so, if you're going to participate in VO, at least, put your effort where your mouth is. And so we spent quite a bit of time re-engineering our own data holdings. So even though this may look similar, we have telescope data products, advanced products here. I'll get into the services later, but this basically has formed on when you click on those icons, you'll go to a landing page, but the query page is the same for all the collections. So we did this by enabling a common data model.
That looks nice. That's great.
This thing?
Yeah, I haven't seen that before.
Okay.
I'm sure we didn't just write a paper on CADC.
Yeah, that's right. That was excellent.
So we transformed all the collections into the same data model. And now a data model is just a way of representing data, metadata. But, every instrument and every telescope has their own FITS keywords. And the way I describe a data model is, you map that into database tables. We're mapping this into the same database tables for all instruments and all telescopes. So this has enabled us to actually have one query interface to all these collections. And, but also supporting proprietary metadata and data access. So some of our collections actually have proprietary metadata. You can't even look at the metadata in the proprietary period. Well, most telescopes actually, it's just the pixels that are proprietary. But this actually supports both. And on the back end, we're using TAP to do this. This has been many years in the making, and I don't know if I should click on that demo link. But I can show this afterwards offline if people are interested. Now, what a data model looks like is, how did I do that? Oh, yes, that's a data model, but I just wanted to show. It's gratuitous.
Can you quickly mail me those slides? Can you just mail me the, is it Keynote or?
I can say I have PDF version.
Okay, can you do it? So I can put it up for people. If that's okay.
Oh, okay. Sorry for the interruption.
Yeah, sorry. We're having problems getting people to.
Oh, this may not fit into a mail message.
Oh.
I can, what I can do is a live demo of our VO space implementation.
Okay. Cool.
So you're getting this demo early in the later. Okay, I'll just find it on the phone. Here. Let's go back. Where's my... there we go. I navigate through this here. This is the PDF. Make sure there are no underscores, just only underscores and no spaces. There we go. File.
So is this a VO? Is this a CDC implementation on top of the VO space protocol?
That's right.
Yeah.
Yeah.
Well,
There we go. And just going to public.
awesome. So
I'll have to send you the link.
actually, all you would have to do is put it in. Oh yeah, actually, yeah. Send me the link. I'll put it up in the chat.
Make sure it's all there. Yep. So that's been a demonstration in geospacing.
Fantastic. Ready for prime time. Yeah. More ready for prime time than Google Hangouts is.
So, okay. Too frothy. Yeah, well, that should work.
Cool. Awesome.
Okay, and back to the regular scheduled programming. Okay, so we were talking about data models and common. So from metadata side of our operation is because we have this common data model, we provided tools for the client community to actually create XML descriptions of an observation with the metadata and a persistence service. So they have a tool for persisting for free. We have Python and Java libraries and an application to help create these XML files, and then they persist them. So actually now, for example, JCMT creates their own. The data used to arrive to us, and we would then take a database description of this metadata and transform it into the data model. But now we've pushed that upstream, so actually the data providers are actually providing us the metadata in the format that can go directly into the archive metadata collection. So it comes into the service, it goes in here, we have access control on that service, so not everybody can put there. And then we have these metadata applications that take both the access control information as who can access these things, and then we populate the query database. And then this query database, we have TAP, the web service on top of that, which is a IVOA protocol. And then client tools and UIs can then query the metadata collection. And that query interface you saw in the slides basically uses this protocol to talk to the service. So our interface actually uses the same protocol as the user. And then anybody with knowledgeable TAP query capability can query the collections on their own. And I'll talk a bit more about that. But all the data model code and descriptions are in Google Code repository, which we now will be moving to GitHub because Google Code is being deprecated.
So is that kept up to date?
Yes,
Okay, right.
yes, the model's up to date.
So if something hasn't been updated in a while, it is because it hasn't been updated in a while.
That's right.
Okay.
That's right. But the same tools can be used for user publishing. And this is the thing is we're looking at community data coming back to us, we're saying if you can take these libraries and actually format your metadata into this data model, we'll publish it through the same channels. So don't have to create a special mechanism for community data. It's all there. It's all web service, and we're prepared to work with the community on using the data model. Now this mapping here is where we've actually invested quite a bit of science time, because data engineering is difficult. It's difficult so we're actually helping people understand how to map their metadata into this data model.
How many different data providers do you have now?
Well, all the collections you saw have been mapped.
Yeah.
Some of them are static, so you're done once. But currently we have, we have CFHT, Gemini, JCMT. We have more UCURT data coming.
But that's multiple instruments from it.
Yeah, multiple instruments, and then also we have our local telescopes as well, and we have our local telescopes and the university telescopes in Quebec, which are sending data dynamically.
And how steep was the learning curve for those data providers?
Once our own data engineers got over the learning curve, it was shortened. Okay, but it isn't easy, because you see, when you're looking at your instrument and your facility, it's very easy to describe it because you know it. But to map it into general terms has been, so you have to get out of your telescope mindset and go into, describing these it's a different way of describing. It's the same information, it's packaged differently. For example, we accept in standard, in predefined units. So, you're going to be milliseconds, or you're going to be arc seconds or whatever, but those are predefined. So you have to transform whatever you have into that.
So who's responsible for the metadata conversions?
Depending on who's putting. We support, for facility telescopes that we support, we do, or we have helped. But it's usually the data provider.
Okay, so that's their responsibility to put the data into your format before shipping it to you.
Yes, and this service actually does validation. But that's the metadata. I'll talk about the data files themselves
That's
later.
a big change from where it used to be. I mean, it used to be that CADC would take the JCMT raw data and the JCMT database tables, and someone at CADC would work out how it mapped to whatever they had. And then they moved it, everything's been moved out to the observatory.
Yeah, sounds like an improvement to me.
Pushing it upstream is good, but you have to help that process. Now, I was going to say, COM is also being used in, we're working collaboratively with SDSCI, because it will form, it'll be used in JWST and will form actually the back end of MAST eventually. So we'll be using that in the model, and we've been working with them on that as well. Now, the other thing this gives us for free is support for these IVOA standards. These just then become views on the data model that we have. So, here are the constraints on those views to support SIA V1, V2, SSA, if we offered the service. I put it up there because we should be offering it, but we haven't yet. And then, supporting the OBS core table as well. So if you look at our collections right now, we almost have 10 million observations in there. And these are our major collections. UCURT, I put it up here because UCURT is not a telescope that we have responsibility for, but we provided the service. So all the data engineering was done by people on staff there, and persisted all the metadata to us through that service. It was we helped them understand the data model, they pushed it. So the beauty of this data model also helps us then support the VO protocols with minimal effort. So that was a big gain. So for current, because we have one interface to all our collections, we can focus all our development effort, and everybody benefits from the new functionality. For example, drill down, single click downloads, auto completion, ADQL editing and submission. So in the query tab here, once you have you can look at the query, and modify it and resubmit the query would be very powerful. We've got a working data link interface as well. And then, improving query performance. We've got lots of ideas on this. But again, it's because we have one interface to everything, it's easy to add functionality that benefits the whole, every collection that we have. This has also led us to do some work on the ALMA Science Query Archive Query Interface. We're currently supporting that as part of the Canadian contribution to ALMA operations. And so we'll be undertaking adding VO interfaces to ALMA in the next year, and possibly even implementing COM, the common model for ALMA collections as well. We're involved with SKA in the science data processor, which is everything from the post-correlator to the user. It's been rescoped last week, and is now 2 telescopes instead of 3. So the survey telescope has been put on hold. And basically, we've been working on this layer, and it's a very similar idea where you have a common model in the science archive. You can support the VO models with views, and you can offer VO services to support all the user query and discovery and access. What's interesting about this is this has to work at the 2 sites early on, but the idea is they're thinking of having regional centers where we're going to take the software stack and just make it run at a regional center, so you don't have to develop interfaces twice for 2 different contexts. So it's an interesting model where you can run here, run there. It's the same software stack in all locations. And more, I think, a little bit of credibility in an LSST building here, talking about to LSST people and others, is our first time series data has gone into COM, and this is our Canada's first and only space telescope. But it's an interesting collection, very small community accessing it, but it is time series. So we've had to look at how to package time series data. And we're talking about pixels here. We haven't actually done databases yet for this. So that's basically CADC activity. And now I sort of want to move into CANFAR. So what is CANFAR? Well, I call it an ecosystem for data-intensive astronomy. And it allows users to do a bunch of interesting things, but as users, but using infrastructure that isn't our own. And this allows us to be able to meet the needs of the community. But we have an integrated authentication authorization. And this is the thing that makes the whole thing work, is that you tie all these different archival data, user data, processing, and resources that are not in your building. Now, we would have had to build this if the community hadn't requested it. And what happens is that we've got more and more survey science being done in Canada, CFHT and JCMT. And these science teams were faced with large data sets. When you have a large data set, you have to look at your data management of your project, the data distribution, the data processing. Basically, teams either did not have the ability or did not want to undertake the responsibility for building infrastructure for their 3-year project that they wouldn't use afterwards. So, this is one-time building of project. There are university buildings in Canada that have clusters in the basement that are mostly idle because the massive data processing task was done for this survey. They've gone on to do other things, and the thing's idling. And you don't necessarily have a strong central presence that can go and get the grant necessary to buy the equipment to operate. So this is the context that CANFAR rose. People were coming to us, can you help us process our data? Well, we didn't have the infrastructure to do that. But then we have this thing called Compute Canada. So think a bit like Exceed, I think, here in the US. We have this big, relatively well-funded infrastructures. But the funding agencies were saying, well, why should I pay for your cluster? Go talk to Compute Canada. They've got cycles. But for data-intensive astronomy, users weren't taking this up. So the solution to this problem was actually resources over there, users over there is connecting the two. So basically built a platform to allow these two things to merge and support basically community projects. And I mean projects, survey projects, but not necessarily survey projects, but really any community project that they can come to us. We have a science management committee. They take requests, which are one paragraph. I need this to do this science project. They get an allocation, and then off they go. The idea is to put things in the user's hands. So using virtual machines, creating virtual clusters for processing, providing them with group management so they can manage their access and their users. And we use VO standards within this infrastructure as well. Now, we developed it primarily, we operate it with funds from, with external funds as well. But we are, CDC now has morphed in being a user of CANFAR rather than CANFAR being a user of CDC. So we are now basically a client of CANFAR, and I'll show you how that transformation has happened. Because the CANFAR infrastructure is serving CDC. But here's just a little list of all the projects we are currently supporting. And they've come to us and said, we would like time and we would like, storage space. And it's proving successful. And I'll talk about the problems near the end. The most successful part of it is our VO space implementation. And it's used for results there, and you share them. And then also for asynchronous query in and out. When you're querying the databases, you can store your query results there asynchronously. This uses UWS in the background for managing asynchronous requests. So we have a browser user interface that you just saw demonstrated about 15 minutes ago. We have Python clients. You can, for example, you can VCP. We have VLS, all the common things, vsync, to sync two different directories. You can mount it, mount VOFS, and all this is available on in GitHub. Again, full access control on this. And also, you can set up notifications so that, and this is in the team sense where you have, a geographically distributed team. Team members can actually set RS feeds on certain directories, so when somebody finishes processing, they actually get notified with actually an email coming to them. The file show up. And, oh gee, I forgot to take that one out. There we go. So VO Space, we enable these RSS feeds, for example, with views. And views are basically moving the code to the data, to the file itself. And so the types of views we support, for example, we support cutouts out of VO Space. WCS, FITS header. So these types of operations, which have traditionally been on the archival data, now work on user files as well. So by using these capabilities in the VO Space spec to enable this. So you saw this a few minutes ago. I won't show you this again, but this is how it looks like once you've mounted your VO Space here. There, you could just do a listing, LS, or conversely on my Mac, this is how it looks like as well. And then, like I say, we have things like VCP, VLS, vsync, which are also used by users. Now, how this changes is, the amount of data we handle now is dominated by users. So, like I said, in the last year, we basically moved the petabyte of data. This is mostly users retrieving data for processing, and this is persisting processing products and sharing data. In terms of scale, our peak week in 2014 is 39 terabytes was moved in and out of VO Space in a week. and 11 million files in a week. So, you know, we're a victim of our own success, by the way. You know, we wish success on people, but it was painful. I'll get more to this.
What's the size limit per user?
Oh, allocations minimum is a terabyte and then goes up from there.
Yeah.
And it's either by user or by project. We like to assign it to projects because it's really a project support platform. But some users have allocation.
Do users have resources allocated to them through Compute Canada outside of Canada?
Any user can go to Compute Canada and ask for an allocation. Yes. And the reason they use this is because it ties so many other things together for them that they don't have to worry about. Giving permission to people to share files when you're running on Compute Canada environment is not obvious. And this, you know, this is why I put VioSpace first. It's our most successful service because it is the collaboration space teams need. And managing access to what and where files exist has been the most used service, part of the service. What this shows is that on project teams, you have a few people generating the data for the teams. So this is puts. So from Asia, you know, you can see where teams are working and files are persisted to CANFAR over here. But here's the true collaboration aspect of it. This is where this is just VioSpace, it's not the archive. This is just VioSpace. So I don't know what that is, but it's probably the Maldives or something. But that's where, you know, you can tell a lot. Now, why this goes in, you know, our geolocation doesn't always work, so it picks the middle of the country sometimes. I mean, there's no one in Canada there using astronomy data. But so there it is. So it's, you know, if you make like this talk I just did, I made the file public, so anybody can retrieve it anonymously. But I don't have the percentage breakdown between authorized access versus public access, anonymous access. But this is where really shows the power of a shared data space for our users.
Do you have an idea of the ratio between puts and gets? Just out of curiosity.
I could get that for you, but gets dominate.
Oh, sure, yeah.
But I mean, those arrows sort of indicate that too, but I don't have the.
I'm just curious if it's like 100, 1,000, you know, what's the ratio?
I could get that number for you. So how this is built and operated. So we have our VioSpace web service, our client tools, VioSpace metadata database here, access control operates and all this. But symmetrical with this is our data web service, which is used for archival data. This is the telescope data that we have a mandate to curate. Now, if you notice, underneath is the same system. So a file, an archival file, is using the same system as a VioSpace file. And what you should take away from this is that the VioSpace file is as secure as that archival file. And since our primary mandate is to curate this data, preserve it, that means we're doing the same thing over here. It's the same system, backed up the same way. We actually have 4 locations, 4 storage sites. And so when data comes in, you look at the metadata databases here, the tools then get redirected to these transfer web services that live at each of the sites, and the data then flows back through here or comes in through this way. So this is handling the persistence or the fetching of the data. We're moving to having local cache stores here, as well as and the advantage to that is we're moving to neighborhood puts and gets. Depending where you are, you may optimize the fetching or the persisting of the data to a neighborhood. And because a lot of our storage is next to processing, when you actually persist or fetch a piece of data for processing, you'll be fetching it locally and not moving it over the WAN. So it keeps things, and this is all configurable, neighborhoods are configurable. For example, you know, we're having 2 projects underway right now. I'll talk about this later, but we're going to have one of these in Europe, and we're going to have one of these in Hawaii at CFHT. so that when the telescopes persist their data, they'll come in here to Victoria, they'll say, where do I put it? Their tool gets redirected, and they'll actually end up putting it at Mauna Kea. Underneath, we have a migration tool that basically propagates that file slowly in the background to all the sites. So it's all synchronized in the background. So it's actually performs. What we've had, the benefit of this is now we basically have about 13 gigabits per second network to the entire collection, whereas before we had a 1 gigabit. When it was all stored at CDC, we had a 1 gigabit connection. Now we effectively have 13 or 14 gigabits we can move data over. So that's helped parallelize the data distribution. So the second most used service obviously is access control here. So we're actually using X509 certificates, but we also support username and password logins and on the command line tools, and we also support header cookies as well. But we use X509 underneath because you have all these different services that you're acting on behalf of the user. And so underneath, we have self-signed certificates. They're accepted by our users, and users don't ever have to know they have a self-signed certificate floating around. But that's how we propagate the user's credentials through the system. And that was one of our major challenges. So just to show you the interface they deal with here, they have so these are a set of groups that I either belong to or I own. So here are the owners of the groups. The administrators are people who can add users and remove users. So just because you're the owner, you don't actually have to be the person administrating the group. And this is the comment that I've made in the past, is, for a PI, and basically the allocation goes to the PI, but the administrator is probably some postdoc, making sure the team members are all in there. And then you can edit the member list. Underneath, what happens is when you get a piece of metadata that is proprietary, we record the fact that you were added to the group, you were removed from the group. We also record you got this piece of metadata or this piece of data because you were a member of the group X. So we can always tell if a user, why a user, under which permission, they were able to retrieve a piece of proprietary data. So that's, or protected data, non-public data. So we have that traceability.
So Severin, is this the same group management that is in the archive side for the data retrieval, or is it two different ones? If I have a project, if I have a, like, I don't know, I run Androids or whatever, do I authorize people at each side, or does it inherit?
It's the same system.
It's the same system.
It's decorated differently.
Okay, that's fine. All right. So as if I add my student, they get access to everything.
Yes, yeah.
It's project. It's
You
entirely project based.
You can take a PI group from a telescope project and give them an allocation. It's the same. It can be the same group that owns the allocation.
Very nice.
Archive groups, user groups. The difference is the user defines a group, or the telescope defines a group.
Does Gemini have some particular problems? Because there's a Gemini DAG files group. Not for any other telescope.
No, this was temporary. Is that there's a bunch of Gemini files from very early on that have metadata that makes it uningestible into the archive.
Just blame Paul Hurst for it. It's just right there,
Yeah,
Paul's problem.
because they want to know what these are, but there's no way to retrieve them out of the archive since the metadata is not there for them to click a button and retrieve. So we just gave them to them. It was an interesting little project.
So do the users have to be into the system first before you can add them to the group?
Yeah, yes, they have to have an account. Yeah, and there's no criteria for getting an account other than they have to be associated with astronomy. So they have to be in some astronomy institute, some university, just, we're not giving accounts to everybody. We do some vetting, but the only vetting we do is this email address, university address, institute address, or is it a Gmail address? If it's a Gmail address, we respond to you are. So again, user client tools to create groups. These are all web services, so you don't have to use the interface. You can actually just put in a curl command to create a group and to set a user in that group. So for example, the data providers, the telescopes, now we're moving them to using, rather than giving us the group information, is we're allowing them just to create the PI group for that program and setting the owner of that group or the administrator of that group to the PI. And so they, again, pushing things upstream where we're used to do that. Now, the telescopes can do that themselves and users can create, but it's the same service underneath.
And I seem to remember one of the nice things about it is that you can have multiple administrators.
Oh,
So
yes.
you have the PI, and the PI blesses the postdoc who's actually going to do all the work, and they can deal with the logistics management.
That's right.
Which is very nice.
Yes.
How does the observatory know which John Smith is the John Smith in CanFile that's relevant? Is it
We
email
used to
or-
ask people for their CDC username.
No, we used to do that, but we don't anymore.
But you do now.
We did it.
You would have to do that now. You'd have to ask for their CDC user name.
The same on GitHub, you have to ask somebody their GitHub ID
Yeah,
to add them to
okay.
your project, right?
Same thing.
Those make it right.
It's the glue, and it's the thing that was the toughest to do because we said, getting naively, use X509 certificates. That's what they're there for. What is in the 509 certificate? I don't want to hear about this. I just want to use my username and password.
But you couldn't a way for me to ever get issued one.
That's because you're a troublemaker.
Now the issues with national issuing agencies, right, and things like that. So it's nice that we sort of.
But you can get a proxy certificate off of your account if you want.
So what's the mechanism? So somebody has an account, and then essentially their username is associated with a behind the scenes X509 for them.
Yes.
Right.
Yes, and you could actually get a 2-week X509 certificate to use on your desktop.
Okay.
So if you want to use these, any of the, file access tools or group management tools from your desktop, command line tools, you can actually download an X509, a proxy certificate. So the utility we give you says get cert, puts it in the right place. Our software looks for it there.
Awesome.
Experienced users will like to use and will download an X509 rather than embedding username password in their script, which they used to do. Not all of them do that. They still embed username passwords in their scripts. So our batch processing service is a service we offer to users, so they can get an allocation. I want so many core days or core years of processing. And again, it's integrated with the same access control system, but we have recently moved away from Nimbus to OpenStack, or rather Compute Canada has moved away from Nimbus to OpenStack as the back end. So we've really spent the last year trying to get this working. It's a batch processing system. Essentially, you're talking to Condor. So you're submitting a bunch of Condor tasks. But in your Condor submission, you say which virtual machine you want to use. And when you submit that file, it goes to a processing web service. Again, you can use it from your own tools, from your desktop. You can submit it using your certificate. You can log into a head node that we have that allows you to submit from there. But again, it's a web service. And it makes sure that the VM is available and you have access to it. Make sure that you have an allocation in OpenStack. And then once verified, submits it to Condor. This is the piece that ties it all together here, because this thing looks at the Condor queue and says, oh, there's a task, it requires some VMs. How many VM spaces do I have in OpenStack? Well, let's boot 20 of them for this user, or let's boot 50 of them, or 100 of them. And it manages, plays nice with all the different users. And, you can have, and so once your 100 VMs are booted, you now have a virtual cluster. And they start consuming jobs out of the Condor queue. Underneath, your credentials are in your VMs. They get passed in. And this was another tricky part. But now you need to get a file out of VioSpace or persist a file out of VioSpace, your credential has been passed into your VM and it all integrates. And that was one of the trickiest parts that we had to deal with. Now, outside of the VM is we actually have agreements with the providers here we manage our user base within these Compute Canada facilities. And it's very crude at the moment, that's why it's a dotted line. But we're actually, in the next release of the OpenStack software, we're gonna actually be able to manage our own domain, and our domain allows us to manage directly our users and our allocations within OpenStack. So, and this is our main processing engine now. In fact, we have no more capacity within CDC for batch processing. It's being turned off and everything's migrating there.
So is VioSpace backed on OpenStack services? Like, is it in Swift, or are you building something out of Cinder, or is it a separate system?
It's a separate system, yeah. And there are reasons for that. Basically, there is no, Compute Canada isn't managing object stores for anybody right now. They're experimenting, but they're not there yet. So we're managing the object store. The other thing we offer is interactive and persistent virtual machines for users. So in part of your allocation, you can say, well, I want interactive virtual machines because I need a 64 core, 256 gig machine to do my ALMA visualization on. And I can't buy one of those. Well, here, boot one up, install your software, interact with it. The other thing we have is persistent virtual machines. And these allow teams to offer software as a service, and I'm going to get into this, using containers, where they can run a software as a service or run discovery agents that are monitoring things, and these just persist. So, they're not batch processing, they're an instance that's launched. You can manage it with clients and tools that talk directly to Nova. You don't even have to be using the interface. But again, we're using this path for authentication and authorization. Now, the container thing is one of the most things we've done. And, but again, it's tying the authentication into this, which was the challenge. So you have a virtual machine that has IPython notebook host. And this is how users explore the space. So a user comes in, and I'll show you, basically clicking a link on a team web page, launches a session, and there's a Docker management that has to script your containers. But when you're coming in authenticated, it actually goes back to the access control service, gets a scope token for VioSpace, and then mounts VioSpace versus the public VioSpace, or mounts the team VioSpace with the private data versus the public data, which gets mounted. So you have a directory structure for your team. You have one directory that's public data because you want to share with a wider community. You have another directory that's private. In that private, you only want team members. So you authenticate, you know what groups this user belongs to, they get a scope token. So you mount the VioSpace with that user's credential. So that now a user is using this Docker container, or the notebook in the Docker container, but mounting the VioSpace. So, authentication authorization has to flow right through there to allow that to happen.
So the fuse mount is inside of the container?
Yeah.
So do you have to run it as a privileged container then to do that?
We haven't worried too much about how these things cross over because the teams aren't worried about it.
Okay.
So this is the team we did this work with and for, but you can see how they have, basically on the web page, you click on the public access or authenticated access, and then what happens is a Docker container boots very quickly, and then, but they end up in an IPython notebook. On the back of this thing, this is also, there's huge data cubes on the in the VioSpace, and what it allows users to basically explore that data space without having to move the data. Basically, the VioSpace is co-located with the virtual machine environment, so there's fast connections in there. But again, exploring large data spaces without moving the data is what this allows. I can demonstrate this afterwards. It's kind of cool. You end up in an IPython notebook, and they know what to do. They can plot things, and so what we're doing, like I mentioned, moving more of the identity and authorization into Compute Canada. We have to do some work with machine image mirroring into different instances of OpenStack. A lot of VO space improvements, scalability, robustness, as you guys have seen, for example, with the mounted file system, fuse file system, decentralized persistence, so this neighborhood persistence, and then working with containers a lot more. And what we really want to get to next is really offering database services for users. So users can create their own databases and offering a tap service on top of these databases with authentication, so they can create a project database only available to their team. They can make a public one. And if they want to build a web interface, a browser interface for this, the tap, they can just use the tap on the back end to query, just like we do for our interface. You query tap, you get the results back, you display. So this is I think in the next year, we're going to have to really address this because there is a demand for this. And as you guys have properly identified as well.
Are people using Julia for real? Because they're talking about it, but I've yet to find somebody who's actually honest to God. Are they?
It's one of these things that, a list of what users would like, but we actually haven't seen any implementation of it. But it's there on the list because someone's asked for it.
Someone asked for it.
This concept of providing community services for communities or projects to explore, I'm really happy to see it's starting to become an idea that's being accepted and implemented elsewhere. So the European Space Astronomy Center with Euclid and Gaia and all their major projects, they're starting to invest. For example, here's their prototype Neo Space browser. And they're starting to develop this idea of collaborative workspaces as well. And this is great. And then our colleagues sitting around the table from across the street, the Data Lab, very similar thing, where you're providing services, database services and collaborative storage environments to support teams and users working with big data. So you don't want to move the data to the user, you want to move the user's processing or requests to the data. And that's, again, we see that in this high-level architecture diagram from the Data Lab group. And as I mentioned before, we're starting this project with Europe and especially with OAT in Trieste in Italy, where basically they're going to move, this was just announced last week, so this is quite fresh, where we're going to basically start, they're going to basically start looking at providing research collaboration portals for astronomy. And basically we're going to start with a CANFAR node there, and then they're going to start building their own infrastructure and replacing pieces of the CANFAR infrastructure with their own, federated cloud environment. So, the ideas are propagating. One idea we've had, for example, to serve Asia is to have a CANFAR node in Asia, Taiwan specifically, to serve that, as more Asian partnerships are, Mauna Kea was where our primary telescopes are. The nature of the national flags of Mauna Kea are changing, and it's quite interesting to see. It's shifting to Asia. So having a presence in Asia and then helping them sort of develop their own, collaboration platform, is an opportunity for us. So I'll come back to this briefly. So I hope, you can see that these services, CANFAR and CDC now are indistinguishable. You could see the two sides of those diagrams. You sort of have the CANFAR side and the CDC side, but ultimately they're using the same infrastructure. all web services, different ways of interacting with these services, and we handle a lot of data right now. And you know, VioSpace has been a very difficult service to ensure performance, and we've been trying hard, and hopefully within the next 2 weeks we'll actually have a major improvement because we're releasing a new architecture for it, and deployment architecture for it, and hopefully we'll have a much better performance out of that. So I'll wrap up quickly here by talking about Virtual Observatory. All this work has led to a new perspective for us on Virtual Observatory. So you have all these data models that we're supporting, different services. You know, access data is basically cutout service for now, credential delegation, all these things. If you're using CDC services, you're using VO services, as you are if you're using CANFOR services. So what does this look like? Well, here's a schematic of our architecture at some level. The green, this is supposed to be yellow up here. It doesn't appear very yellow. Does it appear yellow to you? Anyway, it's supposed to be yellow. This is not green. But green here are the VO services. The green arrows are the VO protocols talking to those services. The blue is CADC software. And this, again, the green is, green arrows are the VO services. So we have across here, the major services. The hash lines here it means it's an upcoming service. We think that the group management service and the processing service could be maybe one day future VO standards. Maybe by having other implementations of this type of community support, you know, there'd be a realization that something like this would be a useful feature to add to VO, especially if we start thinking of interoperating or federating group management systems. The red lines are internal APIs. But what is CDC here? That is roughly what CDC is on this diagram. So using these things, these protocols here. What is CANFOR? Roughly that. Using these other services. What junction here is that there's this common piece, if you want, that is shared. But you know, the data services, because we're using this transfer service, which sits in CANFOR, you know, there's no data storage within CADC anymore. It's in CANFOR. So that's what I mean. CADC is now a client of CANFOR. And but this is how we've made VO protocols now are part of the architecture. They're not additional things. And because of COM, we can support VO data models with simple views. And but we're reusing all these standards, even for our own interfaces. So you can come in directly with a tap query. If you have your own, you can write your own tool to do that. You can do your own query to SIA, or you can come in through our own interfaces. All those are available to you as a user. And I think that's the last point I wanted to make. VO has moved not to the top layer, but is inside the operation of both CANFOR and CDC. And I'll stop there. Anything that you want to see, questions, now's the time.
Okay, so I have one from Shichin remotely. So, you know, you used to be a Sybase post and now so PostgreSQL on the map. Are you deliberately migrating from one to the other, or are you letting them coexist, or what are your database plans?
Our database plans. I think we'll be off of Sybase within 3 years. Sybase is there, was there primarily for replication purposes from STSCI and JCMT. But as we move to this more metadata model where we're going to be pushing metadata descriptions in the data model XML. And I think for future, for both HST, JWST, and JCMT is now doing it, we will no longer need Sybase, and we will more than likely move off of it as our last commercial piece of software. So, you know, Postgres. The idea of SQL is also being talked about. If we ever get into large catalogs, maybe QServe and MySQL will be used, but we're planning on phasing that up.
So if you had a clean sheet to do this again today, for authentication and authorization, would you do X509 again, or would you look at like opens or something else?
It's currently the only thing that will work in all contexts right now.
Does Pat still love X509?
No one loves X509.
Okay. He loves it compared to everything else was about it.
As long as you use it internally, and you need to use it internally, as long as you're using it internally, it doesn't mean you can't use something else on the outside, right? But internally you saw there's a lot of different services that interact here, and you have to pass credentials, and X509 is pretty well the only thing. It sort of translates through all these different services. It's painful.
That's what I was thinking.
But as long as you don't expose users to it, development teams can deal with that kind of pain. Users cannot. And so that's why we brought it all inside and just take care of it for the users. So, but yes, it's the only game in town between. Remember, our services don't always, if you had a nice big Dropbox allocation or an Amazon allocation, or you were able to buy all the hardware you wanted and run it internally, you wouldn't have to deal with some of these issues. Our reality is that the way we could offer this community is to take someone else's hardware and make it useful, available to that community. So it's a different use case. Doesn't mean that it applies across the board, but it does mean that you have to deal with different challenges in integrating all these various providers of resources. So it's made our system in some respects more complex, but in other words, it does allow us to scale out where we couldn't before. And this is the beauty of what we've done, is that as long as Compute Canada keeps saying yes to every time we ask for an allocation. So we ask for the allocation for CAN4. So those petabytes are awarded to CAN4. Internally, we divide them up to the different projects and to CDC. But again, it's all using someone else's resources.
So if Compute Canada reduce your allocation, you have to delete data?
Compute Canada reduce our allocation, there'll be very upset users in universities that they listen to. So it's not CDC that asks for the reallocation. It's the Science Management Committee, which is it's not a governing body per se, but it is the community committee that oversees CAN4 and to some degree CDC activities. So it's a steering committee. They get together twice a year and I give a report. And they look at what we're doing and say, yeah, this is good. And they keep approving it, so that's good.
So within the NRC system of approving projects, when somebody comes and says, okay, I want to build a super collider or something, and I'm going to need all of these compute resources for it, is that something where they start to scope and resources from Compute are allocated at that level? Or is it once that project's funded, they then go and make an application separately?
Projects, well, this is Compute Canada policy, right? But a new project, when you're starting to think about a project, like a few years ago, we started thinking we may have be join the Euclid consortium in Europe, and we would take on the processing. Well, we would have needed so many core years of processing and so much, I think a few petabytes of storage extra. So we went to here, heads up, we'll need this in 2018. So we'll give them some advance notice. Doesn't mean they'll be able to guarantee it, but at least they can roll it into their planning. And the beauty is that right now in Canada, big data is a very hot topic. So anytime you come with a big data project, funding agencies tend to be listening, and that's good. It's good for us. It's good for astronomy. Yes.
So when a user uses CADC and asks for a digitized sky survey image,
yep,
could the data actually be in Ontario? When it's served, or
yes.
Okay.
Well, not that we have data in Ontario, but if we had,
yeah,
good. For example, the offsite storage, we have 2 sites. One is in Saskatchewan, which is a very seismically stable area,
okay,
and the other one's at the University of Victoria, which is next to us. But you'll be redirected. The client tool will be redirected to either a one of those 2 sites.
Okay.
So you'd be coming from the UVic, University of Victoria, or the University of Saskatchewan storage system. So, if you follow the redirection, that's where you'll end up, and that's where you come from.
so you no longer have racks of
Oh no, we have, but the neighborhood concept
yes,
says, you're off-site.
right,
We have 1 gigabit, they have 3 or 10. You're going to go there. We'll send you there. So it's just to optimize the data delivery as well. It's round robin once you're outside the CDC neighborhood, then it's basically, random.
Yeah, if you do a bunch of W gets
Yeah.
in a row, you'll see alternating Saskatoon.
oh, okay,
So I know traditionally there's been the great metadata quality problem with various observatories giving you metadata of various quality. What is the situation with user-contributed products? Do they have to match the quality of the original data source, or is there a higher bar, or is there a lower bar? What is the if I want to ingest some community contributed or collaboration contributed data, how does this happen in practice?
If it checks syntactically,
Right.
we accept it.
Wow.
It is attributed to the project. So yes, users may come to us and say, this is bogus. And what we will do is direct them to the provider.
Right.
So they will see CDC serves up bad data, and that's the risk we take.
Right.
But we cannot curate
Okay.
user contributed.
But it's siloed in some different way from there. So if okay, TMT, right? So you have a product from the telescope and it has a CAOM model and it's has a whole bunch of metadata. Now Beth comes from her survey and she gives me a bunch of GCMT data, and maybe half the headers that would have been in the original data aren't there. Is this representative still? Are you trying to fit the community contributed data in the same data model, or is it completely different?
Yes and no.
Okay.
So a user contributed data to us the files go into a VO space.
Okay.
And then they can be attributed a URI.
Okay.
And so then they can generate from their metadata the XML description. Now, right now we're only offering them COM, but we will also offer them the ops core metadata at the minimum. This is the part we haven't done yet, but we will then ingest that into a user database, put a tap service on the front of it. Users will be able to, we'll register it, users will be able to find it, but we won't build a query interface for it. They will have to build a query interface for it, but they can because they have all access to the tap service.
Ross, the JCMT legacy survey was intending to have a different plan where JCMT would mediate.
Oh, I know. I'm just wondering what's happening in practice with the stuff that you're given.
For certain collections, it's not really user data, right? It's coming from the telescopes, UCUR, JCMT.
Yeah.
It's coming from telescopes, so they're trusted.
Yeah,
and they can go
that's
into
not
this.
user data. No,
It's the user data.
I'm talking about the science collaboration,
Yeah.
sending stuff.
The user data any arbitrary user could ask for an allocation in the hopes of publishing. I think this is what Data Lab's trying to do as well, is allow publication. And the way we're looking at it is VOSpace and a user database that persists, both persist, and then you can write whatever from your web page, query form, or whatever. But we just provide the infrastructure at a minimal cost to us, because we're not paying for the storage and we're not paying to operate the database as well. We do have some operational load, but we will not curate the data. You'll just persist the metadata, and we're not curating it. And if a thing fails, then you have to fix it, right? I mean, if you fail ingestion of metadata because it's tactically wrong, too bad.
Are you doing that cool thing you were talking about where you can issue a DOI to somebody's VM?
Yes, I didn't show that.
So people, so what is DOI'd is the VM and anything that had, what is
So
the actual?
you can get a DOI to a specific VOSpace directory.
We give a
which is
user a
is it a
VOSpace.
snapshot of that VM?
We give them a VOSpace directory.
Okay.
They put data in there, they structure it however they want, they put a README file there. And they can play with that as long till the day that the DOI is published. We issue the DOI.
Okay.
So it goes in the directory name, there it is. When it's published, we freeze it.
Okay.
It's not the user's, it doesn't belong to the user. The user has read permission in it, but we retain ownership. And then when we freeze it, then then we freeze it. So, but that's done with VOSpace. That's another advantage of having VOSpace, is it allows users to then, we don't have to create the DOI data. We do not create it. We cannot, we will not. It's user contributed.
But the point is they can then put that DOI in the paper and somebody else can come and reference the DOI and retrieve that.
Yeah. So far we have two.
Is one of them Tim? No, okay.
No, both of them are because of
Both of them are because of you, yes, but they're there.
We clearly need you to send you to evangelize this a little bit more. Yeah.
Yes, somebody has to promote that. The service exists. Yes,
So is
Ken?
CAMPHAR being used to serve in cosmological simulations? These are huge data sets.
The new grid page I showed you, and I could show you that. It's doing nucleosynthesis and it's telling about. They're big data sets, big cubes on the back of those.
Yeah.
So we're not using it to generate those, because CANFAR processing is for embarrassingly parallel types of data processing. So image processing, essentially, where you're just going through a bunch of files and processing them. Whereas this type of stuff requires MPI, simulation stuff. It's not. Typically, the simulation community has been well served by national infrastructure. The data community is not, and that's the one we're trying to address. But visualizing and exploring the data, where the data sets have gotten too big to move around, that's where CANFAR comes in, with these persistent VMs that allow these Docker sessions to run visualization for users.
And do you support any ability from users to publish their own service? So, you talk about letting them write their own query interface on top of their tab layer. Is that then an open, is that accessible to, can they publish that interface to?
Yes, they will get a persistent VM allocation.
Okay.
If they want to tie it close to the data, then yes. They could host that web page on their website, on their own site, if they wanted to. I mean, because it's all the services are accessible. I mean, it's not, the web page itself doesn't have to be hosted.
Sure, but it can.
But they could ask for an allocation to host a service. It'd have to be more than a web service, because frankly, you can do that. Most campuses have that facility.
Right.
But for the NuGrid project, where you want to move visualization close to the data, that's a justification for having a persistent VM for community. And then within that VM, like I say, you can just run Docker containers for the visualization. So it's good technology. It's fun.
And so what do people tend to use for visualization?
Right now, this is our only visualization. We're going to work with ALMA as well, to the new ALMA visualizer to look at the ALMA data cubes. This is a project we have with the University of Alberta and is being funded by ALMA actually to do that. And the same thing is moving visualization software into a container so that users can actually look at their own data or in their VO space or whatever. Yeah. Lots of activity.
Any questions? All right.
Okay.
Anybody? I mean, just check. Yeah, we're all good. Okay. Thank you very much. Excellent.
Thank you.
Thank you. And going off.